Hello, I am on page 21 of the Unit 7 packet, and what we're going to be talking about in this video is the first two probability rules on this page. All right, so you can actually turn right to page 22 and let's take a look at the first rule, which is called the complement rule. Okay, so the complement rule, it's pretty straightforward. When you see the complement, you're thinking about the word not, okay? The complement of a set is the set of all possible elements that are not in the set. So, for example, if I said, oh, let's look at this. Here we go. Event A, it will rain today. The complement of the event A is it will not rain today. So, for example, let's just say the probability that it will rain today is 1/5. Its complement, the probability that it will not rain today, is 4/5. Okay, so altogether it adds up to 1 whole. Now, the complement, you would either write it like this, A complement, or this little symbol also means A complement. Okay, so this is the notation for the complement. So here, the probability of not A or the probability of A complement, whether you write it either one of these two ways, is just equal to 1 whole minus the probability of A. Okay, so let's keep that in mind, and let's take a look at some of the examples on the bottom of the page. So number 31 says, suppose the probability that a particular flight is on time is 0.78. What is the probability that the flight is not on time? All right, so we see this word not, and that tells us we're looking for the complement. Now we know the complement would just be 1 minus the probability of that event happening. Okay, so if we did 1 minus, we know the probability of the event happening is 0.78. That would mean the probability that the flight is not on time is equal to 0.22. Okay, if you wanted to change it to a percent, you could write 22%. That's up to you. Okay, number 32. So Kendra makes 4 out of every 5 foul shots. So basically, the probability she makes a foul shot is 4/5, right? 4 out of 5. What is the probability that she misses her next foul shot? So basically, what is the probability that she does not make the next foul shot? Okay, so let's take 1 whole and subtract out the probability that she does make it. Okay, so 1 minus 4/5. So 5/5 minus 4/5 would be 1/5. So the probability that she does not make the next foul shot, or that she misses the next foul shot, would be 1 out of 5. Okay, and then finally, let's see, we have a multiple choice down here. If A and B are complements, then which of the following is true about the probability of B based on the probability of A? Okay, so if A and B are complements, let's look at these. Then, all right, I'm seeing it right here in choice 3. The probability of B would be equal to 1 minus the probability of A. Okay, so just remember, if you want to find the complement, you just do 1 minus the probability of the event occurring. So that would be choice 3. All right, so if you can turn to the next page in your packet, page 23, we're going to be talking about the second probability rule of conditional probability. Now, whenever you're talking about conditional probability, really, we're looking for the word given or something that implies the word given, right? Like we know the word if implies given. Okay, so if we look here, this says the probability of A given B is going to be equal to the probability of A and B over the probability of B. Okay, you see it over here as well. This is our conditional probability formula. The probability that A occurs given that B has already occurred is equal to the probability of A, remember that symbol means and B, over the probability of B. And I just want to point out this symbol right here, look right here, this symbol is representative of the word given. So when you see this word, this symbol, it implies given. All right, so let's take a look at number 34. So number 34 says, historically, a given day at the beginning of March in upstate New York has an 18% chance of snow, a 12% chance of rain, and a 4% chance of rain and snow. Okay, I'm going to organize that information on top of the problem real quick. Okay, so I just organized that on the top, and instead of writing them as percents, I just changed them to decimals. Okay, now it says here they want us to calculate the probability of rain given snow. Remember that symbol means given. Okay, so I just copied the formula from the top of the page, except instead of using A and B, I used R and S. I'm just using R for rain and S for snow. So the probability of rain given snow would be equal to the probability of rain and snow over the probability of snow. All right, so I'm glad we organized everything at the top because this will be nice and easy now. So in place of the probability of rain and snow, we can plug in 0.04. And then in the denominator, in place of the probability of snow, we can plug in 0.18. Okay, so that right there would be equal to 0.22. It does say to the nearest percent. So even though that rounds to 0.22, if we move the decimal place over twice to the nearest percent, that would be 22%. Okay, so the probability of rain given snow is 22%. And think about what that means, given snow. Doesn't that mean, another word for given is if. If it snows, there's a 22% chance that it will rain. Okay, so they do say they want you to explain its meaning in the context of the problem. I mean, technically you could write the probability of rain given snow is equal to 22%, but what does that mean? They want you to explain it. So if you were to say that, in a sentence, we know that given, another word for given is if, so I would say if it snows, and I was more specific, on a given day at the beginning of March in upstate New York, there is a 22% chance that it will also rain. All right, number 35, the math department had to report to the Board of Education concerning students enrolled in higher level math courses. The report indicated that 18.4% of the senior class were enrolled in AP Calc, 12.4% of the senior class was enrolled in AP Stats, and 3.6% of them were enrolled in both. Okay, I'm just going to organize that information. All right, so it says find the probability to the nearest hundredth that a student is enrolled in AP Calc, so the probability of Calc, given, so I'm going to use that symbol for given, that he or she is enrolled in AP Stats. Okay, so we're finding the probability of Calc given Stats. So we know that's going to be equal to the probability of Calc and Stats over the probability of the given statement. So the given category is Stats. All right, so we organized everything from above, so we could see right here that the probability of Calc and Stats is 0.036. We see the probability of Stats is 0.124. And they want us to divide these and round to the nearest hundredth. All right, so that gives us 0.29. All right, now in part B, it says explain to a board member that may or may not understand statistics what this means exactly. Okay, I want to point out, this does not mean that there's a 29% chance that a student is enrolled in calculus and stats. Okay, we know there's only a 3.6% chance that a student is enrolled in calculus and stats. What this means is if a student is enrolled in AP statistics, there is a 0.29 chance that they will also be enrolled in AP calculus. Okay, so if a student is enrolled in AP statistics, there is a 0.29 chance that he or she will also be enrolled in AP calculus. All right, so if you can turn to the next page, page 24, we're going to take a look at these three examples, and then that's it for today. So you may want to hit pause and try out number 36 on your own just to see how you did. It's similar to the last two that we did. Okay, so I first just organized the information on the top here. It says that the probability of Key Club is 2.3%. The probability, I use P for physics, AP physics, the probability of being in physics is 0.086, and the probability of being in both is 0.019. Okay, so I just changed the percents to decimals. Now it says that to determine the probability of P given K. So the probability of P given K is equal to, and I just, this is the formula from the previous page, just change your A's and B's to P's and K's. So it's equal to the probability of P and K over the probability of K. All right, so we could just plug in the numbers. So the probability, this says K and P. It's not the same thing as P and K. Doesn't matter what order you put them in. So that's going to be equal to 0.019. And in the denominator, the probability of K, we could see is equal to 0.023. Okay, now they want this to the nearest tenth of a percent. So first of all, if you write this as a decimal, right, it would be 0.8261. So if we change this to a percent and round to the nearest tenth, that would be equal to 82.6%. Okay, so the probability, well, let me say it like this. If someone is in the Key Club, the probability of also being in AP Physics is 82.6%. And actually, they do say to write a statement relating your calculated probabilities to student enrollment in the given situation. All right, so let's write that out. Okay, so if a student is a member of the Key Club, right, given Key Club, if a student is a member of the Key Club, there is an 82.6% chance that he or she is enrolled in AP Physics. All right, 37. Which situation best describes conditional probability? So conditional probability, what we're looking for is the word given or something that implies given, like if. All right, so if you look through the answer choices, I see it right here in choice 4. Finding the probability of an event occurring given another event had already occurred. Okay, so as easy as that. All right, number 38, that's the final one we're going to do today. Now, the first thing you may want to do is just organize your information. So it says the probability that a resident of a housing community opposes spending money for community improvement on plumbing issues is 0.8. So I'm going to say the probability of, let's say, opposing plumbing, I'm going to call that OP, is 0.8. The probability that a resident favors spending money on improving walkways, given that the resident opposes spending money on plumbing issues, is 0.85. Okay, that's very wordy, so let me write that out. The probability, no, it says that a resident favors spending money on improving walkways. So how about we'll do favors walkways? So the probability of favoring walkways. Okay, then I see the word given, so let's put our little symbol for given. The resident opposes spending money on plumbing. So didn't we call that OP for opposing plumbing? Is equal to 0.85. So that was super wordy. I mean, you may have to read that a few times. You may have to go through that super slow. All right, it says determine the probability that a randomly selected resident opposes spending money on plumbing issues and favors spending money on walkways. Okay, so let's write that out. We want to find the probability that a resident opposes plumbing and, so let's put that symbol for and, favors walkways. Okay, that's what we're looking for. I'm going to call that X. Okay, now if we look at what we're given here, right, we can use our conditional probability formula. I'm going to write this out. I'm going to write this right here. So the probability of favoring walkways given opposing plumbing, wouldn't that be equal to the probability of the and, right? The probability of favoring walkways and opposing plumbing over the probability of the given statement, which is opposing plumbing. Okay, so now that we have everything written out, we're just going to plug in the numbers. So we know that this right here is equal to 0.85. So on the left-hand side of the equation, I'll replace that with 0.85. Okay, and then our numerator, this right here, is equal to X, right? We don't know that. And then we know the denominator, the probability of opposing plumbing, is 0.8. All right, so we're almost done. If we want to solve for X, right, since it's x divided by 0.8, isn't the opposite of division multiplication? So let's just multiply both sides of the equation by 0.8. So this 0.8 on top cancels with the 0.8 on bottom, leaving us with x. And if we multiply those out, we get, I'm going to put a 0 in front, 0.68. Okay, so that right there is our answer. So that was complicated, that was wordy, but you just had to go through slowly and, write out everything they give you, write out the formula, and plug everything in and solve.